Alright guys, my apologies for the disturbance, but alright. So first of all, how do we solve trigonometric equations where angles are in degrees? First two steps are just to check whether the angle is consistent with the range. Then find a basic angle, that is alpha. Using ASTC, you will determine the quadrants in which the answer lies. Use these rules to find your answers wherever they lie, and finally give the final answer in the basic way that was initially given, or that is the range of x in other words, usually. This is the graph we will be using, ASTC. In the first quadrant, all functions are positive, sine, cos, theta. In the second quadrant, only sine is positive. In the third, tan is positive. In the fourth, cos is positive. So, how do we solve these equations first of all? These are the basics. So, the first step is to check whether the given angle is consistent with the range. Yes, it is. So, so in this case, we don't need to alter the range. Then we need to find the basic angle, that is alpha. We'll find that using sine inverse of 0.5. Alpha turns out to be 30 degrees. Make sure that your calculator is in degree mode. Then we know that this 0.5 was positive, and sine is only positive in the first and second quadrant. So since sine is only positive in the first and second quadrant, the next step is always, I advise that you do make this graph. So it will hardly take you guys 15 seconds or somewhat similar, but you should always make this graph and show the basic angle. Then finally give your answer in the basic range. In the second quadrant, the angle will be found as 180 minus alpha. Thus, the final answer is 30 degrees and 150 degrees. Then, our second example. The angle is consistent with the range. Thus, the next step will be to find the basic angle, that is alpha. You will find that using cos inverse of 0.5, which turns out to be 60 degrees. Then, again, I always advise that you do make a graph, and cos is positive in the first and fourth quadrant. Thus, we have 160-degree basic angle here and 160-degree angle here. And I'd also like to recap the properties of basic angle. Basic angle is always between 0 and 90 degrees. It's and it is always positive. So. Then we need to find the final answer, which would be, since cos is positive in the first quadrant, it's alpha, and in the last quadrant, we'll use the formula 360 minus alpha. Thus, our final answer turns out to be 60 and 330. 300 rather. Alright, then we have tan x is equals to 1. The angles are consistent, thus we don't need to alter the range. The next step is to find a basic angle. So tan inverse of 1 is equals to 45 degrees. Once you found a basic angle, the next step is to determine where the answers lie. Make this graph again. So tan is positive, 1 is positive, thus tan is also positive, and tan is positive only in the first and third quadrant. And also remember that alpha is always made with the x-axis. It is always made with the x-axis. Alpha is always is always made with the x-axis. Finally, finding the basic, finding the final answer. In the first quadrant, theta is equals to alpha. In the third quadrant, theta is equals to 180 degrees plus 45 degrees. X is equals to 45 degrees and 225. And then we have tan square is equals to 3. The first step is to simplify this and also to check whether the range is consistent, which it is. Then you root both sides in order to simplify, and we have plus minus root 3. So tan is both positive and also negative. Thus, we need to consider all four quadrants. I wrote this down here. And finding alpha. For alpha, I'll only consider positive root because alpha can never be negative. Thus, we will only consider positive root. And alpha turns out to be 60 degrees. We will plot a graph of ACC again, and thus we have something like this. Because tan lies in all four quadrants in this. We have a 60 here, 60 here, 60 here, and a 60 here. Then the final answer would be in the first quadrant too, also in the second quadrant, also in the fourth quadrant, and also in the third quadrant. In the third quadrant, it would be 180 plus 60. In the fourth quadrant, it is 360 minus 60. And thus, our final answer turns out to be 60 degrees, 120 degrees, comma, 240 degrees, and 300 degrees. And by the way, I'd like you guys to note that the final answer should always be given in ascending order. Then, a few more examples. So, in this case, sign is positive. We do not need to alter the range. Thus, I start by finding the basic angle. Sine inverse of root 3 over 2. Alpha turns out to be 60 degrees. Then, we will plot the graph. It can be rough, but again, always make it. Sine is positive in the first quadrant and in the second quadrant. Thus, we have basic angles here, ASTC. Then, our final answer in the basic range between 0 and 360. And x turns out to be 60 and 120 degrees in the first and second quadrant respectively. Then cos is negative in the second and third quadrants, and we do not need to alter the range. Thus, we start by finding the basic angle, which turns out to be 3 over 2. I ignored in this negative sign, ignore when finding alpha because basic angle can never be negative. My my basic angle alpha turns out to be 45 degrees in this case. Then I'll plot a graph of ASTC. Again, cos is negative in the second and third quadrants. I only ignore the negative sign to find alpha. Thus, we have a 45 here and a 45 here. Thus, we do not need to ignore the sign when finding. Do not ignore when determining quadrants. in which the answer is. Alright folks, then ASTC again. Finally, find the values of x. In the second quadrant, we have 180 minus 45. In the third quadrant, we have 180 plus 45. The values of x turn out to be 135 degrees and 225 degrees. Then we have this. Tan is negative in the second quadrant and in the fourth quadrant. And the angle is consistent with the angle in the range. Thus, we do not need to alter the range, and we can start by finding the basic angle. So tan inverse of, I'll ignore the negative sign again, root 3 over 3, since alpha can never be negative again. Alpha can only be positive, and alpha turns out to be 30 degrees. We will plot a graph of ASTC. Tan is negative, I repeat, in the second and fourth quadrant. Thus, we have a 30 here and a 30 here. ASTC. Then, start by finding it. So, in the second quadrant, we have 180 minus 30. In the fourth quadrant, we have 360 minus 30. Thus, we have x as 150 degrees and 330 degrees. This is our answer to this trigonometric equation. And finally, we have sine square x 0.25. The angles are consistent. We do not need to alter the range. Thus, we start by simplifying this first. We will root both sides. Thus, we have sine x is equal to plus minus 0.2. A plus minus since we took the square root of both sides, and it can be positive or negative. Then sine will, the values of x will be found in all four quadrants since we have both plus and minus again. Then we start by finding the basic angle. Sine inverse of, we will only consider 0.25 since alpha can never be negative and alpha turns out to be 30 degrees. We will use ASTC. I'll zoom in. Sine was to be found in all four quadrants. Thus we have something like this. Then finding x in all four quadrants. In the first quadrant, it's alpha. In the second quadrant, it's 180 minus alpha. In the third quadrant, it's 180 plus alpha. In the last quadrant, it's 360 minus. And x turns, the values of x which we have turn out to be 30 degrees, 150 degrees, to 10 degrees, and 330 degrees. Let's move to examples where we have to alter the range. So, in this case, the angles in the range and uh, the angle in the range is not consistent with the angle in the equation. Thus, we need to alter the range. And we will multiply everything by 2. So, we have a 2x here. Then 0 multiplied by 2 is equal to 0. 360 multiplied by 2 is 720 degrees. This is our final this is our final range. And then we have and then we need to find alpha. So we have sine inverse of 0.4. Alpha turns out to be 23.0 degrees. 6 degrees rather. 23.6 degrees is alpha. Then sine is sine is positive only in the first and second quadrants. Thus, we will find x. We will start with 2x since that is in the question. So we have 2x is equals to the first quadrant, just a second, 23.6 degrees in the first quadrant, and in the second quadrant we have 156.4 degrees. This is not the end. We will still continue because see, in a graph of AST, we have 123.6 degrees here, 123.6 degrees here, and this is 0, 90, 270, and 360, and 270 rather. One cycle is of 360 degrees, but in the range we have a 720 degrees. Thus, we will take one more cycle. And to account for that one more cycle, we have a few more. We have two more angles rather. We will just add 360 to the first one. That is 360 plus 20, 3.6 degrees, and 156.4 degrees plus 360 degrees. And 2x turns out to be 23.6 degrees, 156.4 degrees are as they are, and we have 383.6 and 5164 degrees. We will divide everything by 2, and thus we have x is equals to 11.8 degrees to one decimal place because it's in degrees, 78.2 degrees, 191.8 degrees, 258.2 degrees. So one more important point is that the final answer is given in terms of x. And the reason for altering the range was that it helped us decide till what degree shall we go to. Like in this case, the maximum degree can be 720 degrees if it's 2x, and we have four answers. If we did not alter the range, we might just end up making the mistake and get two answers, whereas there are four answers. Then we have this, the angles aren't consistent again, thus we need to alter the range. We will multiply everything by 2, so we have 2x lies between 720 degrees and 0 degrees. Then we start by finding the basic angle, cos inverse of 0.25, and alpha turns out to be 75.5 degrees. We make the graph. Making the graph will also avoid making mistakes. The chances of error, that is. And we also have a 75.5 degrees here because cos is positive only in the first and last quadrant. Thus, we have 2x is equals to, we have to go till 20 degrees. So, first of all, we have alpha moving from 0 to 360. That is. So, we have a 75.5 degrees. Then we have a 360 minus 75.5 degrees. And then 2x is equals to 75.5 degrees is equals to 360 minus 75.5 is equals to 284.5 degrees. Since we have this and move this to the left of it, so we have 284.5 plus 3, or wait, first of all we have 75 plus 360.5 plus 360. Then we have 284.5 plus 360. So we can accommodate the range. And thus we have 217.75 and 322.25. The final answer needs to be in the basic range. We will divide everything by 2. Thus we have a 37.8, a 142.3, 217.8, and a 322.3. And this is our final answer, and answers in degrees are always given till 1 degree. This is finally our second last example. We need to alter the range again since angles aren't consistent. So first of all, multiply everything by 2 and then add 30 to everything we have. And we altered the range. Altering the range again helps us to decide the range, like till where should we go to in order to find that. And it helps us to find the final answer. Again, alpha can never be negative, thus ignore the negative sign when finding alpha. And alpha turns out to be 14.5 degrees. This sign again will help us in determining the quadrants in which the answers lie. Sign is negative in the third and fourth quadrant. Thus, this is how the graph will look like. Then we have 2x plus 30 degrees is equals to, the first answer we have is 194.5. Then we have 360 minus 14.5 is equals to 345.5. And how did we get this? Again, for those who still don't understand, it's 180 plus 14.5. 345.5, 360 minus 14.5. And then we have a 194.5 plus 360, simply because we have to go till 750. And we also have 345.5 degrees plus a 360. Thus, 2x plus 30 turns out to be 194.5, 345.5, 554.5, and a 705.5. You will subtract 30 from everything. Thus, we have a 2x is equals to 164.5, 315.5, a 524.5, and a 675.5. Divide everything by 2 and give the final answer till 1 decimal place. Rounded off till 1 decimal. Thus, we have 82.3 degrees, 157.8 degrees, 262.3 degrees, and a 337.8 degrees. Again, the final answer in degrees would be till 1 decimal place. Then our last and final example is this. First of all, alter the range, multiply everything by 2, thus we have something like this. Then subtract 15 from everything, and our range looks something like this. So 2x lies between 0 degrees, no wait, minus 15 degrees and a 705 degrees. Finding alpha, cos inverse of 0.75, alpha turns out to be 41.4 degrees. Cos is positive in the first and last quadrant, thus our graph would look something like this. This is also a 41.4 degree because the basic angle is always made with the x-axis. Then we have a 2x.15 is equals to, first of all, in the first quadrant it's alpha, in the second quadrant it's in the second quadrant it's 360 minus 41.4, which will give us 318.6. In the last two quadrants, it's the first two answers plus 360. 318.6 plus 360. Solving for the right hand side, we have something like this. Just a second. 41401.4 and a 678.6. We will add 15 to everything on the right hand side, and also like if minus 15 goes there and it becomes positive. Thus we have 2x as 56.4, 333.6, 416.4 and a 693.6. We will divide everything by 2 and give our final answer to one decimal place because it's in degree. And finally 346.8. And this is our final answer, and you can also confirm this answer because if this does not match with this range, you realize that you have to reject one of them. And then lastly, answers in degrees should always be given to one decimal place, and in radians should be given till 3. So this is how we solve trigonometric equations in degrees.